Yeah, I hope my screen is shared. Right. See, I'm let me introduce myself before moving further. So I am Shiva. So I work as trainer in DurgaSoft. I have I am also working as an DevOps engineer in IT industry, and I have overall 8+ years of experience. And I work with multiple technologies like AWS, Docker, Terraform, Kubernetes, Jenkins. Okay, I also work with Spring Boot and Maven, and I also work with different production-based issues, and I write scripts in order to automate the task, automation scripts actually, and I hold multiple certifications actually. So I hold AWS Developer Associate and Terraform Associate, okay, and Kubernetes Certified Administrator certifications. Okay,
Yeah.
that is my short introduction about myself. And today the webinar topic is how the industry how the people will be deploying their applications on the servers or on the Kubernetes cluster by following some methodology. How they are going to do that with Docker and Kubernetes, and what is that process? And we are going to do we are going to see each and every step as part of the diagram today, and we are going to see some projects that will be included that are part of my course starting from tomorrow 8 a.m. morning. Okay, so let's go move further. Before going further, if you have any questions, you can ask. If not, we'll move further. Okay. Yeah, we'll move further. If I hope it's not actually. So what will be happening in real time industry? Okay, developers will be there, and they will be writing their application code. Here we are going to take an example of Spring Boot application. That means the Java application. Okay, Spring Boot. Okay, Spring Boot application. Spring Boot application, I'm taking an example. Okay, now what the people does in industry is developers will be developing their code, their code with the functionality they want. Okay, and they will be writing unit test cases is also written by developers, and they'll be writing the unit test cases. And what they'll do, they in order to perform unit testing, they'll write the unit test cases. And let me draw a diagram that one. Okay, he suppose he is the developer, and he was assigned a project that to develop an application. So he has developed an application, something called web application. It contains some APIs and some functionality, and he has developed an application. What he will do after developing an application, he will push his code to version control system. That means whatever it is, there are many version control systems available in industry or in market. So one of the example is GitHub or Bitbucket or whatever it is. So I am taking an example of GitHub. Okay, GitHub. Okay, right. Once he developed his application, his code will be pushed to GitHub. Actually, he will push his code to GitHub repository. So once the code is been pushed, right, this code cannot be directly put on the servers to deploy our applications. This code cannot be directly put on the server. It will not work. Okay. Now, this code will undergo many transactions in between transitions. Okay, many transitions in between our development as well as deploying our application to the servers. Actually, what transitions it undergoes actually. Now what they will do in industry, once the developer has pushed his code to GitHub repository, what they'll do, they'll try to create a jar file out of this Spring Boot application. They'll try to create a jar file out of this Spring Boot application. Let's think this is the jar file that is created. This is the jar file that is created. This is a jar file. Okay, now let me name it as jar. Okay, this Spring Boot application jar file. Okay, now this jar file which is created out of this project, out of this application, what they'll do, this jar file there will be something called Docker file. Docker file will be there. Docker file. Okay, this Docker file, what they'll do, they'll include this jar file in this Docker file. How they will include this jar file in this Docker file? We have how to write a Docker file, we have separate instructions, and people uses those instructions, and they will include this jar file into this Docker file, and they will create a Docker image out of this Docker file. Okay, they will create a Docker image out of this Docker. What is Docker file, what is Docker image, that is different thing, but this is how they are going to follow. Actually, this is the Docker file. Actually, let me write it here. Okay, Docker file. Okay, they are going to write something called Docker file, something like this. Okay, this is the Docker file, and this is the Docker image. Let me put like something like this, and this is the Docker image. With the Docker file only, you will be able to create a Docker image. Okay, Docker image, image. Now, what this Docker image contains? This Docker image contains our application, right? See, developer has pushed its code to GitHub. Out of this code, a jar file is generated. This jar file included as part of the Docker file, and from the Docker file, we created a Docker image. That means this Docker image also contains our application code. Our application code. That's what it means, right? Internally contains our application code, actually, right? Now, this Docker image will be scanned with the tool called Trivy. There is some tool called Trivy which is used to scan our Docker images. This is the tool. Let's just think it's a tool that's named as Trivy, actually. Now, let me name that one. Okay. Trivy. Okay, this is the Trivy tool used to scan the Docker images. Once the scan is been completed, and once the verified Docker image does not contain any vulnerabilities, any bugs, or any problems, right? They will push this Docker image. They will push this Docker image to Docker registry. There will be a Docker registry in order to store our Docker images. Like to store our application code, there is a GitHub, right? Source version control system, right? In the same way, to store our Docker images, we have registries, Docker registries, that to store our Docker images. Let me write it here. Okay, let me write it here. Docker registry. Okay, something like this. We will be having Docker registries, and yeah, they will store their the Docker image to the Docker registry. Now, once the storing of the Docker image to the Docker registry has been completed, what they'll do, they will be having servers. Like Kubernetes cluster. Suppose this is a Kubernetes cluster. They will be having this. What is a cluster? Cluster is a combination of multiple servers. Cluster means it's a combination of multiple servers. Suppose let's think this is the cluster. This is a one node in the cluster. We'll call server as node with respect to Kubernetes. Let me copy this. Let me paste it here. Let me copy this. Let me put it here in this place. Something like this, right? So these are two servers within the Kubernetes cluster. Let me write it here. Kubernetes. Okay, NETES cluster. Okay, cluster, right? So this is the Kubernetes cluster, and they will use this Docker image, which is pushed to Docker registry. This Docker image is pushed to Docker registry in this place, and this Docker image, which is pushed to Docker registry, is used and deployed onto this Kubernetes cluster, and our applications will be running in the Kubernetes cluster as pods. We'll call pods in the Kubernetes terminology, actually. So something like this. Our applications will be running as part of this Kubernetes cluster. This is the way people will be deploying their applications to the Kubernetes cluster, actually. And in the middle, there is one more step that is included. after creating a jar file from the Spring Boot application, what they will do, they will push this jar file to what is that, JFrog repository that is used to store artifacts. Here it is called artifact. Jar file is nothing but an artifact. Like, what is an artifact? Like, suppose if you want to send 100 different files to your friend, what you'll do, you will convert that 100 different files into a one file, that is zip file, right? So that zip file is called an artifact. Okay, here also our entire Spring Boot application is converted into a jar file, and this jar file is called an artifact. And this artifact is pushed to what is that, JFrog registry. There are two famous tools in order to store the artifacts. One is the JFrog, other one is the Nexus. And here let's take an example of the JFrog registry. Okay, some industry, there are two popular, these are two popular tools. Some people use Nexus, some people use JFrog and JFrog. Okay, let me take an example of JFrog. Okay, this is the JFrog tool actually. So this is how they will be deploying their applications into the Kubernetes cluster, and they will be scanning for bugs in their application with another step. What the step is, they will be connecting their code to the what is that, sonar cube, in order for the static code analysis. What is static code analysis? That means whether your code has any duplications, whether your code is highly secure, and whether your code contains any vulnerabilities. What is vulnerabilities? That's, as of now, just things as bugs. Okay, that static code analysis is being checked by your Sonar Cube tool. Sonar Cube tool also checks how much code coverage, that means how much amount of test cases has been written in your application. So that is the static code analysis that is done by the Sonar Cube. In this actually, this is the Sonar Cube that we are going to use. Sonar Cube, QUBE. So this is the Sonar Cube. So this is how they are going to deploy their applications to the Kubernetes cluster. It might be the different applications. Okay, I am taking here as a Spring Boot application. It can be a .NET application. It can be a Python application. It can be any application. They will be, if they are following the Docker way of deploying the applications, that is a famous way in the real industry, they will be using same way. First they will be deploying the application, creating the application, they'll be converting an artifact, and they will be creating a jar file. After that jar file, they'll convert in they will create a Docker file, and out of this Docker file they'll create a Docker image. This Docker image is scanned by Trivy, and after scanning, this Docker image is pushed to Docker registry, and from the Docker registry we will deploy their applications, like applications which is pushed to Docker registry to our server, something like this. Okay, this is the way the people use the people will be deploying their applications to the Kubernetes cluster. And there are two other different tools. One is Sonar Cube, other one is JFrog. Sonar Cube is used for static code analysis. That is whether your application contains any bugs, any duplication things, a duplicate code, and they will that Sonar Cube tool suggests a beautiful tool. It suggests this line need to be removed, this line should be public, and this line should be private, and this line is a duplicate code. You can write in this manner also. So such kind of suggestions can be given by Sonar Cube actually, and it will also check how much amount of code coverage is happened in our code. That means how much amount of test cases we have written in our code, in our application code. That is Sonar Cube. And the JFrog is used to store the artifacts. Okay, so see, these things will be happened with each and every microservice. What is a microservice? A small application. Each application, suppose if you have 100 different applications, you will be, this kind of things will be happening, creating a jar file, Docker file, Docker image, pushing Docker image to Docker registry, and from the Docker registry deploying the applications to cluster. So all these things will be happening with all 100 different applications. Okay, that is required. Okay, so that is how people use to deploy an applications to the Kubernetes clusters onto the servers, actually, or the servers. Okay, so as of now, if you are not understanding what is Kubernetes cluster, we will be seeing that in the course, no problem with that. But yeah, just think of the Kubernetes cluster is a combination of multiple servers. Okay, here I have taken example with Spring Boot application. It will be same with all other different applications, whether it is a Spring Boot, whether it's a Python, whether it's a .NET, or whatever it is. Okay, that's how the people use to deploy their applications. So this is the thing, actually. Now, any questions that you have before moving further? Any questions? Okay, if you have no questions, what are the important projects that we are going to see in our course? We will be seeing actually now. Okay, we are going to see 8 different projects in our course. Let me go to my presentation. Okay, this is the presentation I have actually. Okay, so this see this is the presentation I have, which contains the Docker, Jenkins, and Kubernetes automating and deploying and securing applications, actually. So that's the thing. Okay, now the first project in this course will be the project number 1 with the help of Docker and Docker Compose. Okay, we will be having student store application, we will be having student store application, and we will be having MongoDB application. Okay, the student store application will be running on port number 8080, and the MongoDB application will be running on port number 27017. And student store application will be connecting with the MongoDB application on the port number. You can see that this connection on the MongoDB port number. Okay, now how this student store application is created. Suppose this is the student store application. I have written a Spring Boot application code or the any code. Okay, I have written in the .NET code. Okay, for the .NET code, a Docker file we will create a Docker file. Out of this Docker file, we will be creating a Docker image, and we will be deploying the Docker image as a Docker container. In this here, actually, this in Docker terminology, we will tell, okay, we will tell as containers, each application has containers, right? Okay, because of the evolution of microservices, and because of that reason, the microservice like Docker is in container. Not only Docker, container runtime engines are being popular. Like Docker, we have different container runtime engines, container D, Docker, okay, Cryo, something like that. Okay, so here we will be using our Docker file to deploy our Spring Boot application. This is a Spring Boot application that is created from the Docker file, and we are going to create a Docker file with multi-stage Docker builds. Multi-stage Docker builds is very important industry standard. People will be writing their Docker files with multi-stage Docker builds. There will be different stages in the Docker file, and we will copy the required things from one stage to other stage, and we will be creating a Docker image out of that Docker file. From the Docker image, we will be using the Docker image to run as a student store app, as a Docker container. In the Docker container, our application will be running, actually. So that one, if you feel something like I'm talking technical, please bear with me, because this need to be taught as part of the project number 1, actually. So See here, the port number 8080 of the student store application will be port mapped to 8989 of our server. That is called Docker host. We'll call. Okay. In case of Docker, we'll call as server as Docker host. Okay. This port mapping will be happening, and we will be doing that port mappings. And you can see that this port of the MongoDB 27017 will be port mapped to 27018 on the Docker host actually, and we will establish the communication between the student store application and the MongoDB application, because the student store application need to be sending the data to MongoDB application to store the data, and student store application should be able to connect to the MongoDB application to get the data and to give back to the users actually. So this 8989 port that we have port mapped on the server, we will be connecting that 8989 port with the Postman tool. This is one of the tool with which we can send the API request, with which we can send the API request actually. So that's the tool actually. We will send the API request on this 8989 tool, and this traffic will be reached to student store application, and the data from the student store application will be stored to MongoDB application actually. So this see, once the data is stored in the MongoDB application, if you want to visualize the data, you can connect with the Mongo Compass. Mongo Compass is a tool with which you can connect to this MongoDB application, and you can visualize the data. What are the different data that is available in this MongoDB database? Okay, now everything that is an important thing. This is an important which I'm saying. Everything here which you are seeing in this diagram, creating a custom network, creating a Docker file, Docker image out of this Docker file, creating the Docker containers out of the Docker image, and creating this MongoDB container, and this connection, okay, connection between student store application and the MongoDB application, and the port mappings to our Docker host. These two port mappings, okay, 27018 and 8989. Okay, creating the custom network. You can see that creating the custom network. Okay, everything will be automated with the Docker Compose. Okay, Docker Compose is a famous tool in order to automate the deployment of our Docker containers. Suppose if you want to deploy 100 different containers, you need to type 100 different times Docker, something like that. But with the help of Docker Compose, with one command, you will be declaring everything about the 100 different microservices in one file, and you will be deploying with one command and Docker-compose up-d. That's it. All the 100 different Docker containers will be deployed, and they will be ready to serve the traffic. And that is the power of Docker Compose that we are going to see as part of our course. Actually, this is a project number. Entire thing as part of this project will be automated. All the things will be automated. What are the different concepts that I have included as part of this project? Number one is a Docker file, Docker volumes, Docker Compose, Docker networking, and container communication, establishing the communication between two different Docker containers actually. So that is the project number one. Okay, now what is the project number two? Right, this is a project with respect to Docker. Now what is the project number two? The project with respect to Kubernetes. Okay, Kubernetes. What we will be having, this application, the student store application and the MongoDB application. You need to first understand how to deploy these applications with the Docker. Then only you will be understanding how to deploy these applications within the Kubernetes cluster. What we will be doing, we will be using the Kubernetes components. We will be using the Kubernetes workloads, Kubernetes components or Kubernetes services, and we will be deploying that application as in the Kubernetes cluster actually. Here, the student store application will be pushed to Docker registry, that is ECR. ECR, Amazon ECR is an Elastic Container Registry. In order to store our Docker images, and that will be the image, the Docker image will be taken by this from the ECR and deployed into our Kubernetes cluster as a deployment. Okay, what is a deployment? What is the different things we will be clearly seeing as part of the course without any problems. We will clearly understanding that actually, and we will be deploying the MongoDB application with another deployment with as a pod actually, and we will be establishing the communication between our student store pods and the MongoDB pods with the service which we are going to deploy as part of the Kubernetes cluster. If you feel this is a technical, because if this should be explained as part of the projects, this will be very clear as part of the Kubernetes that we see in the course. Actually, that's the thing that very clearly will be explained actually. And we will be seeing in this dynamic volume provisioning, persistent volume claims, persistent volumes, storage classes. We will be seeing we will be leveraging the AWS EBS volumes in order to connect to our application pod, that is our MongoDB pod, in order to store the MongoDB data that is coming from the student store application from these pods actually. And the data which is stored as part of this MongoDB, we are going to take a backup. The backup is very important in case of storing the data, right? Backups need to be there. Right. For backups in Kubernetes, we have cron jobs. We will be leveraging the concepts of cron job, and we are going to take a backup and we are going to save the data for every 1 day or whatever your company or we decide. So that data will be taken as a backup actually. Okay, what are the different things I have included as part of this course? Is I have included the Kubernetes components, that is service, pods, deployments, replica sets, these persistent volume claims, persistent volume, storage classes, cron jobs, and here also liveness probe, readiness probe, startup probes, horizontal pod autoscaler. See, this is a horizontal pod autoscaler is really interesting actually. So suppose today you are getting only 100 requests, 100 people are sending the traffic to your application. Okay, now what happens if the 1,000 people are sending the traffic to your application? Your application may not respond, right? So many people are sending the application traffic, and your application will not be able to respond properly. So in that case, what this horizontal pod autoscaler does? Okay, this horizontal pod autoscalers automatically scales the capacity of the pods, capacity of your applications to serve that much amount of incoming traffic. When the traffic is increased, automatically the capacity of the pods will be increased. When the traffic is decreased, the capacity of the pods will be decreased actually. That is the importance of horizontal pod auto scaler. Okay, that is the important thing. Okay, we will be using secrets, config maps, we will be using sealed secrets, we will be using resource requests and limits, resource quota, namespaces, limit ranges, jobs, and cron jobs. And we will be connecting this service with the Postman, and we are going to send the API request through the Postman, and we are going to store the data as part of this MongoDB. And if you observe this pods from this deployment will be this require a Docker image, right? The pods require a Docker image. The Docker image will be taken from the ECR and the Docker image. This is the MongoDB Docker image. Okay, MongoDB that is taken from the hub.docker.com, that is Docker Hub. We are connecting with different registries as part of this project actually. Please understand how important this project is. In the same way, in what way our company used to deploy the applications in the Kubernetes clusters or the servers in the same way, or adding some other topics. So in the same way, I am going to tell you as part of the project 2 and as part of the remaining projects actually. So this is the project number 2. Please understand the importance. Okay, now that's the thing actually. Now, what's the project number 3 that we are going to see here? The project number 3 is, this is the project number 3. Okay, now if you go to different projects here, project 1, project 2, project 3, the complexity is going to increase from top to down. Okay, the complexity of the projects is going to be increased from the top to down. Here, the extra things that we are going to add in this project is security, cluster role binding, role binding. That is RBAC, role based access control for our Kubernetes clusters. And we are going to include the ingress controllers. We are going to see host based routing and path based routing in with the Kubernetes clusters. Okay, we are going to see this is the ingress controllers that we have. That is Nginx ingress controller and the Kong ingress controller. We are going to leverage any one of the ingress controller. We are going to see the two as part of the project. We are going to see any one actually. So what is this ingress controller? Ingress controller will be acting as a gateway, like it based on our APIs. Okay, if the /test API comes, if the user sends, suppose www.youtube.com/test, okay, that API is /test, then the request goes to this service. If the API www.youtube.com/demo, okay, if the API is /demo, then the request goes to this service actually. Path-based routing will be provided by the ingress controllers. So such kind of things we are going to see as part of this actually. Now, the fourth project that we are going to see is this one, project number 4 actually. So we are going to automate the deployments into the Kubernetes cluster with Helm charts, Argo CD, and we are going to connect this Kubernetes cluster with Kubernetes dashboard and K9s tool, and the Rancher is one of the tool. Actually, we are going to connect this Kubernetes cluster with 3 different tools. Okay, do not worry if I am speaking much technical. If you do not understand, please, these are the projects that we are going to see actually in the course. Please do not worry about that. Okay, very clearly will be understanding for you in the course actually. So that's I think project number 4. And the project number 5 that is going to see EFK stack. These are all the real-time projects. Okay, how to collect the logs from the Kubernetes cluster applications. Applications will be deploying in the Kubernetes cluster. How to collect the logs from the Kubernetes cluster and send that logs to Elasticsearch. From the Elasticsearch, we will be visualizing the logs as part of the Kibana. We are going to see this project as project number 5, EFK stack. Okay, Elasticsearch, Fluentd, and the Kibana. Okay, Kibana. This is a project number 5 that we have. The project number 6, we are going to integrate our Kubernetes cluster with Prometheus and Grafana in order to get the metrics. Nice visualizations. You can see something like this. Actually, what is metrics? How much amount of CPU is consumed by our node? How much amount of memory is consumed by our node? How many amount of requests are coming to our pods? How much amount of outgoing requests, responses are going out from our pod, so from our applications. So such kind of metrics we can see as part of this Grafana dashboard actually. So this is the one of the real-time project I am including as part of this next batch that is starting from tomorrow. Okay, what is the next thing? The project number 7, we are including Istio as a service mesh. You please understand the importance of the projects. Okay, we will be deploying the Istio as a service mesh, and we are going to visualize the traffic, okay, using Kiali dashboard. What is the Istio? What is the architecture of the Istio? What is envoy proxy? And how the Istio encrypts the traffic which is coming to it in the service space. We are going to see very, very clearly as part of this project number 7. Actually, please understand the importance. As I know, as of now, it will be a very new topics to you, but we are going to see each and every topic very, 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 very clearly as part of this course actually. Now, this is a project number 7, and the project number 8 is the entire Jenkins pipeline. What I have explained in the starting of the class. Once the developer has pushed is code to GitHub repository, and Jenkins pipeline will be started. In the Jenkins pipeline, the Maven build will be taken care. Test cases will be executed, Sonar Cube static code analysis will be taken care, and the JFrog storing of the artifact into a JFrog repository will be happening, and creating a Docker image will be happening out of a Docker file, and from the Docker image need to be scanned with Trivy, and that Docker image need to be pushed to Docker Hub, and cleanup activities will be happening, and we will be triggering the downstream. See, please do not worry as of now if I'm speaking about a technical. Yeah, do not worry about that. Okay, we will be triggering the downstream project, a downstream job, which is responsible for updating the files in the in the GitHub repository, and the changes will be automatically detected by the Argo CD, and the Argo CD will be automatically deploying that version of the application to the Kubernetes cluster, and we will be achieving our goal. Actually, once the changes has been done in the GitHub repository, we will be going to get a mail to our inbox saying that the deployment has been done and the application, new version of the application is deployed to the Kubernetes cluster, and you can go there and check whether the application is properly running or not with connecting you with the Kubernetes cluster. Actually, if you will get pods or you will get apps, something like that, and yeah, you can do that. Actually, that is the project number 4. The project number 8, actually, we are including the project 8 different projects with different tools and different technologies as part of this course. And let me go to the course summary, and let me show you what are the different things that we will be seeing as part of this one. 1 second. Yeah, so this is the course content. Actually, from tomorrow I am explaining this one, no problem with that. But you can see the course includes Jenkins, Docker, and Kubernetes, and we designed this course by keeping in mind both beginner and advanced, like beginner and like fresher as well as experienced people. It is taught in a way from beginner, so you can see, understand from where we are starting this course, what is SDLC. From that basics we are starting those course, and we will be ending this course with very advanced, very experienced people, and like you will be very experienced if you practice and if you regularly follow this course. And that's the thing I want to say. If you are aiming to crack an interviews, it is very important to take this course, and you will be successfully get the interviews, get some knowledge on Jenkins, Docker, and Kubernetes, and these topics will be very clear for you. And what are the different things? Jenkins, Docker, and Kubernetes. And if you go down, that important part I want to show in this course is we are going to use 28 different tools as part of this course. You can see that these are the different tools we are going to see, we are going to use as part of this course. You can see that 28 different tools. Yeah, you can see that here, and we are going to use this Amazon Web Services services, EC2, and load balancers, container registry, Kubernetes service, Elastic Kubernetes service, VPCs, virtual private cloud. So these are the different things that we are going to see as part of the course. 8 different projects and these 28 different tools, and we are going to track our regular work with Jira tool. With the Jira tool, we are going to track that our regular work, where we are and what we need to be done in the next things, and we are going to see as part of the Jira tool, as part of the Jira dashboard, and we will be moving further with the Jira tool. Actually, something like this. Okay, now any questions anyone has? Actually, someone put something in chat. On daily basis, once the class got over, recording will be sent to our mail or not? Yes, on daily basis, once the class has been completed, morning 8 a.m. to 9 a.m. or 9:15 a.m. so your recordings will be there as part of your drive. You are going to get a drive access that is shared with the DURGASOFT, shared by the DURGASOFT, and they will be sending you that recordings as part of your drive, and the documentation will also be shared with you in the drive by me. Actually, something like the recording will be shared by DURGASOFT and the documentation will be shared by me in your drive. Okay, that is the thing. Please understand the importance. 8 different projects, 28 different tools, along with Jira. We are going to use Jira. We are going to leverage the Jira as to track our daily activities, where we are and what need to be completed. Okay, something like that. Okay, that's a thing. Okay, any questions, anyone, please? Any questions, anyone? If you do not want to ask, please that put that questions in chat. Okay, okay. If you do not want to ask, please put that questions in chat. If not, that's the webinar for today. We have seen, let me summarize. Okay, we have seen how the people deploys their applications to the Kubernetes cluster or the servers, and we have seen what are the different projects and different tools and different course content. We will like course content will be explained tomorrow in the classes from 8 a.m. morning. Please go ahead to the DurgaSoft website and register for the course there actually. So that's what I can say. That's it. Okay. Thanks for joining the webinar and have a good day. And we will meet in the next class, that is tomorrow, 8 a.m. morning sharp. Thank you. Thanks for joining webinar. And if you have any questions, still you can ask. If not, we will meet in the next class, that is tomorrow, 8 a.m. morning. Okay. Thank you.